everyone, and welcome to my deployment environment research presentation. I'm Luana Gonzalez, and I'm going to take you through three companies that I researched this week and their deployment plans. So, the three companies I chose are Instagram for their continuous deployment, Red Spot Interactive, they're located in Jupiter, Florida, about an hour away from me, and a web firm called Sun Digital Marketing, which who are about 5 minutes away from me. So it's kind of cool to get in contact with them. So I'm gonna go ahead and get started with Instagram. Instagram, as we know, is pretty big. They are they have over 400 million active users monthly. So there's always a lot of releases, bug fixes, new new um, new features being implemented constantly. So they're pretty robust, and because of that, I've used their documentation, a lot of the documentation that was out there, to learn about how what is their architecture and how they essentially continuously deploy their code per day. So their architecture, I'm going to go run through quickly. There's a lot going on with the application. For operating server, they run on Ubuntu Linux 11.04, and they host it on Amazon EC2. For load balancing, to make sure their server can handle all like those 400 million requests that they get, they use Amazon Elastic Load Balancer with 3 Nginx instances behind it. So if one machine fails, they're taken out of the rotation, so that way Instagram doesn't crash. And for their DNS, they use Amazon's Route 53. For application servers, the application is pretty much scripted on with Python, so they use a Django framework and they run it on Amazon high CPU extra large machines. So they're very CPU bound rather than memory bound. For their WSGI or Web Server Gateway Interface, to configure that, they use GUnicorn, which stands for Green Unicorn. I thought that was kind of cute. But essentially, it's a Python HTTP server for Unix-based systems. And to run commands on many instances, like deploying code, they use Fabric and Python library and command line tool. For data storage, a lot of technologies are used as well, but they mainly use Postgres SQL for user, photo, metadata tags, hashtags that we use, and they use a PG bouncer to connect to their Postgres SQL database. For the physical photos, they use an Amazon S3, Amazon CloudFront as their CDN to manage image load times from users around the world. They use Redis to power the main feed, activity feed, session systems, and other related systems. They use Apache Solr for GeoSearch API and Mcached for caching. I'm just going to run through this really quick, and then just to complete their architecture for their task queue and push notifications, they use Enviroment for tasks. So pretty much those requests that to share an Instagram photo to Twitter or Facebook, or when Twitter needs to notify one of their real-time subscribers for a new photo posted, they push it to Enviroment, and then which pretty much uploads the media quickly while doing the heavy lifting still in the background. Um, and for push notifications, they use PyAPNS, a universal Apple push notification service provider. And to monitor everything that's going on, they use Munin to graph metrics across all of their systems and as an alert mechanism if anything is outside of the normal range. And Pingdom for external monitoring of the service. Excuse me. PagerDuty for handling notifications and incidents. And for Python error reporting, they use Sentry to see errors happening across their system in real time. So we get into their deployment. So they continuously deploy their backend code like 30 to 50 times a day. So whenever engineers commit changes to master, pretty much with no human involvement in most cases. So it's all automatically deployed. Why they do this is because it lets engineers move really fast. So they're not limited to few deployments. Instead, they can deploy whenever they want, which they can iterate on changes very quickly. It makes it easier to identify bad commits instead of digging through tens of thousands and hundreds of commits to find the cause of this whatever new error. The pool is narrowed down to one or at least that's what they mentioned in their documentation, to 2 to 3 errors. And the metrics that indicate the problem can be used to identify the accurate start time, and from there they can find which commits were deployed at that time. And sometimes, even though with continuous automatic deployment, bad commits can get detected very quickly. If bad commits are pushed to production, they can be detected very quickly and dealt with, which means they don't end up with an undeployable mess in the master and cause significant delays for unrelated changes. They're always in a state where they can get important fixes out quickly. So their implementation and principles, I'm just going to go by this really quick because it's a lot. It's pretty dense information. So they have this thing, they call it canarying. So I had to look up the definition for this because I wasn't sure what that meant. They used it a lot, a canary machine. I was like, okay, what is that? But pretty much it's their staging server. That's what I got from looking up what canary means. It's like their staging server where they test all the commits that are being pushed, and to make sure, keep testing them over and over again, to make sure that there's no errors, and to assure that there's a clean push to the production. And they use the term rollout. So I kind of assume that as well as pushing, because they don't use the term push as you use for GitHub. So I guess watch out for that throughout the presentation when I say rolling out, or you see rolling out in the presentation. That kind of means pushing the commit. So the process, how it works, is that once the engineer develops locally or so on, and makes the commits, there's an automated script that runs to test the commits that are being pushed to the canary machine. So once those commits are in the canary machine, the script will run and check all to detect any bad commits and report like a status of each commit and if there's any errors existing. So essentially, they check for the status of HTTP requests that are working or failing. And then more testing goes down once that's through. They use Jenkins, the open source automation server, to run tests on new commits in the master, and they report the results and states as running, if the push is still running, done, an error, and it also warns if a push was getting pushed again. It warns if the previous rollout was not done. Yeah, if it was not in a done state. And then they use an application called Sauron, where so Jenkins push all these results into Sauron, so it's visible and readable. It's kind of like a log that they use to um, keep up track all the commits that are happening. So this is kind of an example what it looks like. So Sauron application, it does full commit tracking. It keeps track of the latest commit that passed test record for every commit in the master and know the test status of each specific commit. And it also gives the developer a chance to change the state of a commit to abort if an error occurs. And when there's diffs, they don't really use Jenkins to check diffs. They use Sandcastle, which reports diffs that have been created or updated. Sandcastle is pretty much a continuous integration system. And then to finalize, this processing, this testing, it doesn't end because they continue to test during code review, and they test before landing and then after landing. Even after it's pushed, they test, and it has to be fast and run often to avoid minimal errors as possible. And then, so with the pass tests, there's additional testing for the commits that have passed. And so they run automatic scripts to make sure if the push was successful. And if 1% of hosts fail to deploy, if 1% of them fail to deploy, the push is rolled back. If all the testing is normal, if all the commits are normal and error free, then the automatic script accepts the suggested commit or commits and starts the staging server again, and then continues to full deployment and uses Jenkins to do the final push, which would be marked as done. Just to conclude, they want to make their engineers comfortable and provide good visibility. So this is one of their principles. There's a lot going on. I just really skimmed through what really goes on with their deployment process because it's a lot of deep details. But they want to provide good visibility into what the system has done, is doing, and what is it about to do, so the engineer can see what's going on before additional changes are made or edits. Another principle they practice is to expect bad deploys. It's going to happen because your some bad commits are gonna get pushed through that are not gonna be detected in this whole major testing process. But pretty much it's okay. They make it to, not that it's okay, but it's okay because of this continuous deployment. Um, they can detect it quickly and be able to roll back the bad commit, the bad push quickly as well. So now moving on to Red Spot Interactive. I interviewed Joe Macheri, who's a software developer at the company. Red Spot Interactive is a marketing company that provides analytics and lead management services to the elective health industry. So they really help them find leads, like doctors who have this huge patient database. So it really helps them improve their website and detect leads and turn those leads into new patients, kind of deal. So they have a return on their investment when it comes to marketing their business. So while talking with Joe, the architecture that they have, it's pretty much Microsoft, and I had to ask him to elaborate because throughout most of my full sale, we've been working with Macs. So it was interesting to get a different perspective how a Microsoft stack would be implemented. So the operating system is definitely it's a Windows Server 2012, and they use a web server, IIS, so Internet Information Services, as a web server. So it's kind of equivalent to Apache. For their database, they use a Microsoft SQL server. And for languages they use, language they use is C#. And they use the MVC framework, ASP.NET with AngularJS to build the websites for these businesses. They use a multi-tier architecture. There's a lot of servers that branch out. They use a server where all their business logic application reside in. They use a separate server for their database for multiple. He told me for security reasons mostly. And websites are on different servers depending on the traffic they get. And which I'm going to be explaining in the deployment process, every website has a QA, a pre-production and production, a QA server, pre-production server, and a production domain. So the deployment is an automatic deployment. The developers test locally first on their machine, and then once all testing is good on the local machine, they deploy automatically to what they call is their QA server, quality assurance servers. So they have people testing, trying to get user feedback on the use of the website or application. Then once all good to go on that end, and all the testing and resolving any conflicts, they push it to the staging server, which they usually call pre-production server, to do final preparations before production. And then finally, they deploy everything to their production server. So some notes he mentioned for the QA server and the pre-production server, commits are automatically deployed. And for production, they use semi-manual deployment. So I guess some is automated and some they have to do manually to push everything. I guess for um, quality assurance, right? Or and so moving on, Sun Digital Marketing. So this company, it focuses mostly on marketing, SEO, sorry, not CEO, SEO and design. I interviewed Trevor Clendenin. He's the technology lead of the company. And this one is actually very, very close to me, which is kind of interesting to learn about a web firm so close to my house. So, the architecture, they they had experience launching robust Drupal applications, but per my conversation with Trevor, it was mostly we discussed mostly on their deployment process for um, like website launching. Uh, they mainly work in WordPress because their clientele is mostly small and medium-sized businesses. So they pretty much operate on a single tier architecture. Um, they use a MAMP stack, so MySQL, PHP, Apache, and their virtual private server runs WHM and cPanel for their websites. So helping to launch their WordPress websites into their hosting server. In their deployment process, Trevor explained to me, since he's the tech lead, he manually sets up every DNS database and file system. So they don't really work on a automatic deployment. They mainly test locally before launching into VPS, so they don't really have like a staging server that they always test on before launching into production. They only do like a staging testing when the client has their own server. So I mean, they primarily prefer to host the client's website for a variety of reasons, like speed, security, and software, but they only provide managed services. So some clients prefer the cost benefits of shared hosting with discount providers like GoDaddy or HostGator. And so occasionally, like I was mentioning earlier, they if they have to use a client server to launch, they set up a subdomain for development, like, for example, dev.yourwebsite.com, in order to test locally and to make sure everything will be a smooth transition to final production. And that is my presentation. Thank you.